Hello students, good morning. Welcome to online learning, standard 12 and subject chemistry. And in this 12th standard chemistry, we have been discussing the lesson 2, that is P block elements 1. And in the previous video, we have seen about alums. And in this present video, the concept we are going to discuss is silicones. And dear students, this is the last concept of this lesson. After completing this, we can continue the next lesson. Okay, so what is the concept of today's class? Silicones are the concept of today's class. Okay, let us move on to the video. Okay, dear students, in this video, what are the things we are going to see? Let us see now. First one is introduction. In the introductory part, some general informations about silicones we have to know. Then secondly, preparation, how silicones are prepared in laboratory. And thirdly, its types, what are the types of silicones. And fourth thing is properties, the physical properties of silicones. And finally, its uses. So these are the things we have to discuss in this video. What are they? The introductory part, its preparation, types, properties, and finally uses. Okay, Mama. So all these concepts, let us see one by one. Okay, dear students, first introduction. Okay, look at the point number 1. What is given? The silicones are also called as polysiloxanes. Dear students, do you know the meaning of the term poly? The meaning of the term poly is many. Okay, and siloxanes. Look at the word clearly, siloxanes. If we separate and see, we can say siloxanes. So here the term sil, S-I-L, represents silicone, and oxane, oxane represents oxygen. So when the units of silicon and oxygen is repeated several times, is repeated many times, what do we get? We get silicones. So these silicones are also called as polysiloxanes. So poly in the sense many, and siloxane in the sense silicon and oxygen units. Okay, so they are called as polysiloxanes. Then point number 2, they are also called as organosilicon polymers. The term organo represents the organic side chain present in the silicones, and silicon is already present. The symbol of silicon is Si. Okay, so they are called as organosilicon polymers since they possess organic part as well as silicon part. So they are called as organosilicon polymers. Then look at point number 3. It's given about the general empirical formula of silicones. What it is? The general empirical formula of silicone is R2SiO. So R2 is the organic part. Here R may be alkyl. The examples for alkyl group is methyl, ethyl, and so on. And for aryl group, the example is phenyl benzyl, and so on. So what is the general empirical formula of silicones? It is R2SiO, and this R2SiO is equivalent to another molecular formula, that is R2CO. Dear students, do you know which kind of compounds are given the formula R2CO? Yes, they are ketones. They are the organic chemistry parts, and their general formula is R2CO. And there is a similarity between R2SiO and R2CO. That is why the silicon polymers are also called as silicones in order to have a same ending. For example, ketone, Ketone. Here what is there? One. Likewise, silicone, Silicone. Here also One. Since they both possess similar empirical formula, they are given the same spelling. Okay, ketone and silicone. Okay, then come to point number 4. What is given here? They may be linear or cross-linked. So it is representing the structure of silicones. The structure of silicone may be either linear structure or it may be cross-linked. Cross-linked in the sense having a structure like a cyclic one, like a cage one. So that is called as cross-linked structure. Okay, so the structure of silicones may be either linear or it may be cross-linked. Then next point. They possess high thermal stability. So high thermal stability in the sense if we heat this silicon polymers to a higher temperature, they won't decompose. There is no decomposition of the polymer molecule takes place, and so they are called as, they said to possess higher thermal stability. So that is given in this point. The silicon polymers possess high thermal stability. There is no decomposition takes place even upon heated at a higher temperature. So they said to possess high thermal stability. They are stable even at a higher temperature. And because of this property, the silicon polymers are also called as high temperature polymers. So what is another name given to silicon? They are also called as high temperature polymers. So dear students, in this slide, what are the informations we have known about silicons? They are also called as polysiloxanes, and they are also called as organosilicon polymers. Their general empirical formula is R2SiO, which is equivalent to the ketone formula, that is R2CO. Then the structure may be either linear or cross-linked. Then they said to possess higher thermal stability, and because of possessing this higher thermal stability, they are also called as high temperature polymers. Okay, wow? Okay, then next we are going to see about preparation, how silicons are prepared. And in this preparation part, I have divided this into two types. One is the preparation of linear polymers, and the one more is the preparation of cross-linked polymers. First, let us discuss about the preparation of linear silicons. Linear silicons are linear polymers. Okay, so they are prepared by the hydrolysis of dialkyl dichlorosilanes. What do you mean by the term hydrolysis? It is the property of a compound to react with water molecule, that is called as hydrolysis. And look at this one, dialkyl dichlorosilane, and look at this formula too. What is given? R2. R is alkyl group. How many R is present? 2. So it is called as dialkyl. Then chloro means Cl. How many chlorines are present? There are 2 chlorines present. So dialkyl dichlorosilane. Silane is used to represent the presence of silicon atom. When this compound is hydrolyzed, when this dialkyl dichlorosilanes are hydrolyzed, and the subsequent condensation of this hydrolyzed product yields the linear silicon molecules. Now look at the equation. This is the equation, shows the preparation of linear silicons. Initially, what is taken? Dialkyl dichlorosilane is taken. What is the formula of dialkyl dichlorosilane? R2. 2R is present. Dichloro, 2 Cls. Then silane, silicon is present. It is on hydrolysis. Hydrolysis means what? Reaction of any compound with water molecule, that is hydrolysis. And while hydrolysis, these 2 Cl groups are replaced by OH groups, so that we get this product RRSiOH. And this product upon condensation in the sense, and just imagine and see another molecule of this hydrolyzed product, SiR, then OH, then here also OH. When 2 compounds are allowed to react, from here OH and from here hydrogen is eliminated, and there is an oxygen bridge is developed between one molecule and another molecule, and so we get a product of this type. Okay, so in this way we can prepare the linear silicons. So how linear silicons are prepared? They are prepared by the hydrolysis of dialkyl dichlorosilanes. What is the formula of dialkyl dichlorosilane? That is R2SiC2. Okay, ma'am. Then next we have to discuss about how cross-linked silicons are prepared, the preparation of cross-linked silicons. Here there is no equation given, only the structure of cross-linked polymers are given, and they can be prepared by the hydrolysis of alkyl trichlorosilane. Alkyl means only one R will be present, trichloro, which means 3 Cl groups will be present, silane, presence of silicon atom. So this cross-linked polymers can be prepared by the hydrolysis of RSiCl3, that is alkyl trichlorosilane, and there is no equation given, only the structure of cross-linked polymers are given. There are 3 structures given. This is one structure of cross-linked polymer, this is another structure of cross-linked polymer, this is also another structure of cross-linked polymers. So how the cross-linked polymers are prepared? They are prepared by the hydrolysis of RSiCl3, alkyl trichlorosilanes. Okay, ma. So with this, the preparation part is over. Then next we have to discuss about the types of silicons. Dear students, there are three types of silicones known. Let us see what are they. The type number one is linear silicones. About linear silicones, we have seen just now how they can be prepared. They are prepared by the hydrolysis of it's given hydrolysis and subsequent condensation of what molecule? Dialkyl dichlorosilane. What is dialkyl dichlorosilane? That is R2SiCl2. So when R2SiCl2 is hydrolyzed and allowed to undergo condensation, what do we get? We get the product linear silicones. Okay, then type number 2 is cyclic silicones. Type number 1 we have seen about linear silicones, and in type number 2 we have to see about cyclic silicones and how they are prepared. It is given that this cyclic silicones are obtained by the hydrolysis of again dialkyl dichlorosilane. What is the formula of dialkyl dichlorosilane? That is R2SiCl2. Okay, then third one is about cross-linked polymers. This is the type number 3. Linear silicones, cyclic silicones, and finally we have to see about cross-linked silicones. And these cross-linked silicones are obtained by the hydrolysis of RSiCl3, that is alkyl trichlorosilane. So these are the three types of silicones. What are they? Linear silicones, cyclic silicones, and finally cross-linked silicones. Okay, students. Then next we have to see about the properties of silicones. The properties are given here. First one, they are water repellent. The silicones are water repellent, which means they won't interact with water molecules. Then secondly, they are thermal and electrical insulators, which means they won't allow heat and electricity to pass through them. Then property number 3 is they are chemically inert, which means they are not ready to react with any other chemical species. Then property number 4 is about the physical state of silicones. The lower member of silicones in the sense molecules which possess a less number of silicon atoms, that is called as lower silicones. And the lower silicones are oily liquids, but higher silicones are waxy solids. When the number of silicon atoms increases, they will be looking like a solid. This is property number 4. Then property number 5 is the viscosity remains constant. What is viscosity? The rate of flow of liquid is called as viscosity. The viscosity remains constant. Even if we heat them, there will be no change in the viscosity. That is given in the next point. They do not thicken during winter. In the winter season, there is no thickening of silicone resins or silicone oils. So these are the properties of silicones. What are they? They are water repellent. They are the thermal and electrical insulators. They are chemically inert. The lower silicones are oils, whereas the higher silicones are waxy solids. Then viscosity remains constant. Even upon heating, there is no change in the viscosity. Okay, so with this, the properties of silicones over. Then we have to see about the uses of silicones. That is given in the next slide. Use number 1 is it is used for a low temperature lubrication and in vacuum pumps and high temperature oil baths. This is the use number 1. And secondly, it is used for making waterproofing cloths. Since we have seen in the previous slide, it is water repellent, so it is used for preparing waterproofing cloths. Then thirdly, it is used as insulating material in mortars. And final uses, it is mixed with paints to make them resistant towards sunlight, temperature, and chemicals. So these are the uses of silicones. What are they? It is used for low temperature lubrication and in vacuum pumps, and also in high temperature oil baths. Then secondly, it is used for making waterproofing cloths. Then it is used as an insulating material. Then it is mixed with paints in order to make them resistant towards sunlight, temperature, and chemicals. So dear students, in this video, what are the things we have seen? We have seen what are called as silicones, how they are prepared, their properties, and finally their uses. Okay students, go through the video and learn well. Thank you.